Hello everyone, and today I'm going to build a second version of my live aviation weather map. Now, I built one of these last year for the San Francisco Bay Area. If you've not seen one before, it's essentially a big map of the area with all of the airports replaced by lights that tell you the weather conditions at that airport. They're a really fun visual piece to hang on the wall, and of course as a pilot it's really nice to be able to glance at the wall and see how the weather is in your area. The one in the Bay Area was like a fun visual toy, but of course the Bay Area's weather is, if you live there you'll know this, pretty predictable. It tends to be what I call late spring all year round, with a couple of seasons of small bits of rain. Here in Colorado we've been having thunderstorms roll in pretty much every other day all summer so far. So I think here it's going to be much more important, especially as I get flying here again and want to just understand what's going on, and also just so you can see from the pattern of lights where the weather fronts are moving across this part of the state. So I, as you may tell, haven't got one on me. That's because this is the start of the build, unusually for me. I'm not going to sit here and talk at you for 20 minutes. Instead, I'm actually going to try and record the build and show it to you in steps. And I didn't quite keep the old map. It was, of course, only really relevant for the Bay Area. So when I moved out here, I tore it down, but I did keep some of the pieces. And so the core brains of it is this. This is a particle photon. It is a small, I'd say Arduino-ish development board that basically comes with built-in Wi-Fi connectivity. The nice thing about particle boards, they do a Wi-Fi range and a 3G range and LTE range and so on, is they kind of have written a lot of the connectivity stack for you, and they have this nice web-based service where you can push and pull and call APIs natively. So if you're doing a very heavy like internet communications-based project, they're a nice leg up to get going, even if they're a bit more expensive. But they have great docs, and one of my favorite things about them is you can just code on the web IDE and hit send, and it uploads over the internet to it, which is just fantastic. So that's me, my brains of the operation. And then for the actual lights, what I'm going to use is addressable RGB LEDs. Now, sometimes you may have seen them looking like this. This is a string of them right here. And the way these work, if you can see, there are 3 wires. And what you can do is you can have not an infinitely long, but a very long string of these LEDs, and each of them has an address, basically one on from the previous one. So rather than having to have like a pair of wires per LED to change what color it is, instead you've basically got a power, a ground, and a data line, and then you can just send instructions down and have the entire chain light up different colors. Now, in this form, they're a bit too bulky. Obviously, I can't just take those, like they'd stick out the back of the thing really far. And so instead, I have the raw set of them here. And the idea is I'm going to take these and place them onto my printed map, which is going to be on like a firm backing of foam core, and then wire them up, and then finally plug my brains here into the rest of the thing. Now you can see the bit of work I did manage to keep here was this baseboard, which gives me the pinout for my LEDs of ground, power, and data. So I'll be keeping that, but the rest of it I'm going to rebuild from scratch, basically. So first thing to do is to get that map and print it out and start getting it mounted. So let's go to the computer and start doing that. So we first need to pull the charts we're going to print off. And here is the kind of chart we're going to print. This is called a VFR chart, a VFR sectional to be precise. Now, there's a couple of different kinds of flying, VFR versus IFR, and this chart is designed for visual flight rules, which is what VFR means. Essentially flying with reference to the ground. So you can see here, it has a lot of ground information that shows you not just mountains and areas like that, but if you zoom in, it also shows you things like where the areas of buildings are, and then railways and other sort of major features like Highway 70 here, which is obviously, if you're flying, a very important visual reference. And if you're flying visual flight rules, like the controllers and the towers will generally give you visual reference points to fly from. And so this kind of map is designed to help you navigate that particular airspace as you look out the window. There's a lot of stuff on here. There's things like altitude restrictions. As you can see, there's lots of warnings. Here, which is especially important in the Rocky Mountains, these big numbers, the 11.8 here, is the minimum altitude you need in that area to not hit the ground. As you can see here, it's 14,600 feet over here in the Rockies. That is higher than any plane I think I've ever flown will actually go, and certainly higher than you can go without oxygen. So these are important charts for pilots. But what we're looking for is the airports. And what you can see here is these small purple dots are all the small airports around Denver and the surrounding area. If I go over here, you'll see more over here, out in the plains. America is just covered in small airports. One of the nice things about the US is that there is this like real commitment to like pretty much every small town that's far enough away from another small town will have an airport. It might just be a simple runway and some tarmac and maybe a hangar, but there'll be an airport you can fly to. Of course, Denver does have a big airport, Denver International Airport. That is the big blue set of runways here at the center of the screen. And that's maybe the one thing we're gonna have to like play with a little bit, but the rest of them, as you see, are small round holes. And what we're gonna do is take those small purple holes, we're gonna punch through them, and we're gonna put LEDs in them that they're gonna shine with the color representing the weather of that area. So my first task is to work out what kind of piece of this map I want to take. So before I sort of try and work that out and show you, there is one problem. And that problem is that these maps generally come in single big TIFF files, which is they're GeoTIFF, so you can stick them into a GIS program, but they're basically single big images. And if you look at this index here of what those images cover, you will see the Denver area is labeled right here, but the city of Denver is actually this purple square between Denver, Wichita, and Cheyenne. And what this means is I can't just download the Denver TIFF. In fact, I can go to Photoshop here and show you what it looks like, because the top right of the image right here is where I live. And what I want is I don't want a image that is literally Denver in the top right and then just loads of bits of the Rocky Mountains for the rest of the map. I kind of want Denver to be in the center. And so what that means is I can't just take Denver, or even the Denver and Cheyenne maps. I have to take all three of them and stitch them together. Now, fortunately, sites like this have already done the work of putting them into tiles. And so what I actually have is a Python script that can download a set of tiles from something like this and stitch them together back into a single image. So once I work out the extent of the area I want, I'm going to basically work out what that means for the tile indices, plug it into my little script, and then have it download and run this stuff for me. That's, by the way, all in a free Git repository. I'll link it, of course, in the description on the video afterwards. But first, let's work out the area I want. So I'm going to be printing onto a 13 by 19 piece of paper. That is 13 by 19 inches, of course. This is the US. Everything must be in inches. It's not free otherwise. And so I have two choices. I can either go portrait or I can go landscape. So let's zoom out here and see kind of what I want to do. Now notice as I've zoomed out, it has gone to the more planning level map. Now this is the kind of map detail you would see essentially when you had like a big wall map in a flight school. They have a huge one that's the whole of the lower 48 states of the US, and this is kind of that level. And so if I hit sectionals here, we'll go back to the higher detail map here. And so kind of what I want here is I want to get a good amount of the Rocky Mountains in. I want to get a good amount of the plains in. And I also kind of want to pull in things like Fort Collins and Colorado Springs if I can. So if we look down here, this is Colorado Springs. And so like, at least in this map, it is, and it still is actually in real life, reasonably close to Denver. Close, of course, in this term being about 2 hours drive away. Fort Collins is even closer up here. And of course, the border of Colorado is a bit north of there. So I think probably what I want to do here is get like a portrait segment that gets Fort Collins and the Springs in, and then has biased a bit towards the mountains on the right-hand side of the screen here. So I think that will be the kind of thing I'm going for. So what I'm going to do is I'm going to cut away, go and tell my program to download roughly that area with a bit of overspill so I can sit there and skew it a little bit myself, and then we'll come back and look at how we can crop it. All right, so I've got the image downloaded after a little bit of faffing with the script, but I'll go into that some other time. And what I've got here is essentially the raw image data. Now, I made it a little bit bigger than I'd want, just so I had space to move around and choose the right crop. My goal here is to crop this to the kind of area that makes sense, that has enough airports in it to be interesting, while of course not making everything too small, because I do have to actually put LEDs in all the airports. So first of all, I'm going to go to the crop tool here in Photoshop. Of course, you're happy to use any crop tool you like. I put in the ratio of the paper I'm using. So I'm using 13 by 19 inch Super B paper, as it's called here in the US. And thankfully the printer I'm using can print on that paper borderlessly. That's really nice. So I can just put in those ratios directly into Photoshop. And as you see here, it's giving me this crop square of exactly what I can crop out. Now, as I said, my goal is to probably get as many interesting airports in as possible. So looking at this, my first instinct is that I do want these airports over here on the left. So what I'm going to do is I'm actually going to take the the crop here. And I am going to drag it a little bit over here. All right, there we go. You can see I can basically like sit here. It's one of the reasons I like use Photoshop for this. You can just pull the crop around. It maintains its aspect ratio pretty well. So I do want to get this airport here in the top left, which is Saratoga in, and I'm going to get Steamboat Springs in down here on sort of the center left. So that's pretty good on that side. I think I also, just for symmetry, want to get more of the Denver airspace rings in. If you're curious, by the way, airspace around big national airports, or international airports in fact, is done on what's called a reverse wedding cake. So it's a series of airspaces that get bigger as they go up. That's what you're seeing here around Denver. But just for that reason, it's nice to have that sort of whole sphere in, because I'm sure as I start flying here more, I'm going to have to learn to really avoid the airspace. You don't want to tangle with commercial jets unless you are really prepared for it. They tend to get a little bit shirty if you do things like hold them up. And the controllers get especially shirty and then give you a number to call. So that aside, so what's nice, this is a pretty good crop, because like what I've got here is I've got a lot of the mountain airports in on the left. Of course, mountain airports are harder to do because mountains, and so we're lucky to have a couple here in Steamboat and Saratoga, and of course here in the sort of the flatter parts of the Rockies between the mountain ranges. And I've got a lot of Denver on the right. I've got Fort Collins. I've got the Springs down here. And then what I do like is I've still got a couple of airports right here on the bottom that I can sort of have a good distribution. So like looking at this, I can see that like I can choose my airports and get a nice even distribution of LEDs and have a good looking kind of weather map out of it. I'm not going to punch out every airport and make a hole for an LED behind it. Specifically Denver, as you can see here, if I zoom in a little bit, it's just chock full of small airports. We don't need all of those, only the major ones. But otherwise, I'm pretty happy with that. So I'm going to take that crop, I'm going to store it permanently. So there is my final image. So I'm going to take that, send it to the fancy printer, get it printed on some nice semi-gloss paper, just so it's not too shiny, and then we'll start on the actual construction. So the printing is done, and we now have this wonderful map here printed out. Now, of course, the first thing to do with a map like this is to mount it on something. As you can imagine, the map by itself is pretty flimsy. It's not going to be able to stand up. And of course, I've got to mount some hardware on the back of here. I've got to put some LEDs, these ones right here. And I've got to put the wiring, and I've got to put some small place for this little microcontroller to go. So with that, I'm going to have to put it on something. Now, there's some options here. You could use plywood, you could use acrylic, you could use cardboard. I'm a particular fan of foam core, which is this stuff, also called foam board, has many other names. It's basically solid foam with two pieces of cardboard on the outside of it. I used this for the last map, it was pretty good. It's nice because it's very cheap and it has a lot of rigidity to it, but it's very easy to craft with. So like I can cut out holes in this pretty easily and cut to size and so on. So first things first, I'm going to take my map here, I'm going to use some spray glue, and I'm going to mount it straight onto this foam core, and then we'll come back and start looking at how to put the LEDs in. So that is the map cut out to size. Now there is an obvious missing piece, which is holes. Now I have to mount these LEDs here behind the map. Now as you can see, if I lay them down, they're about the right size of these holes here, all the markings for the airports. But of course I can't mount them directly on top, because the actual light emitting part is this very central piece here, and the rest of it has to sort of sit on the back against the foam core. So I have here a set of punches. These are just spring-loaded punches right here. And essentially what you do is you take them, you place them on the paper, you pull them back, and that is the punching action. So I'm going to punch out some holes in this map over the airports that I want. But as I do that, I'm also going to make sure that the airports I'm punching have weather information. One of the big mistakes I made on the San Francisco map, or the Bay Area map, was that I actually punched a hole for an airport that didn't have any METAR information. It was too small, it didn't have any readings. So I had to kind of fake that one with another airport that was close by. So this time, I'm going to sit here and look at the airports that are visually in the places I want, then look them up on my computer and make sure they actually have weather information, and then punch the holes. And that's going to take a while, so we're going to go to a time lapse of that, and then when we come back, we should have lots of holes all over the map. So let's go. All right, so I have finished putting the holes into the map. As you can see, if I hold it upside down, it's easy to see them. There's about 20-ish holes here. And I've of course labeled each hole with the code of the airport. So later on when I wire them up, I can get that all programmed in correctly. So one thing to note, you may have seen during the time lapse, I had to use a drill to drill down and mark where to cut the holes and then cut them from the back. Because the foam core is quite thick, if you cut it from the front, you sort of put this dent in it, and like on the front that looks terrible. If you cut from the back, then this front surface lies flush against the cutting mat and you get a nice clean edge. It's basically, that's why I was basically like working at the airports, marking them from the front so I can flip it over and then properly cut through from the back. Could have used a nail or something too, but the drill is what I had on hand here, so that's what I used. So the next thing is to put in the LEDs. Now, as I showed you earlier, this is the set of LEDs. I need to break them off, place them behind every single one of these airport holes, and then I'm going to glue them in and secure them. Now, one thing I want to note, and I'll show you this again in probably another time lapse, is that these LEDs, if you leave them like this, they're pretty harsh, like they're kind of a point light source coming out of these. And so you want kind of a diffuser to go over the top of it. Now, normally you'd have like a little plastic cap, like frosted white plastic that would properly scatter the light. I don't have one of those around, or like even a set of those around. But what I discovered when making the last map is that a dollop of hot glue has much the same effect. And so what I'll be doing is essentially doing two things in one. I'll be placing these in the back and then using tape to seal them on temporarily. I'm then going to be hot gluing them from the front and deliberately leaving a large dollop of hot glue rising above the actual map itself, and let that dry and coalesce into that sort of little frosted white spot that will then use to shine the map light through. So that's the next thing. I'll get the hot glue gun, warm it up, and then I'll get gluing. One quick thing before I get to using the hot glue gun here is just to note some of the small things I'm doing to make sure I glue these correctly. Now, you can't really see it on any of the cameras here. I'll try and get a close up for you. But they have 6 pads on the bottom of them, and 3 of them are in and 3 of them are out. And so I have to lay them out on this, on the back of this thing, so that I can then later on go and solder the wires on them correctly. So that means essentially working out what the path of my wires will be, which you can see here. I've actually traced out a rough outline on the back of the thing. And then I'm going to lay the LEDs down when I glue them, so the arrows point down the path. That means that later on when I come to solder them, which is the most time-consuming and laborious part of this process, that I have a decent chance of all the wires lining up and not getting too much wire strain. So that's just a quick note. Now the hot glue gun is almost there, so we'll cut to a time lapse and I will start gluing these in. All right, so now I've got all of those glued in. I'm going to show you what it looks like up close with this close-up camera here first, like that. So it's a little bit frosted, and they get more and more opaque as time goes on. And what that means is after about an hour or so, they are quite frosted. Now, of course, I could do things like using the laser cutter here and just laser cut these holes and then cut small circles of frosted acrylic. That would be cheating. It would be too easy. This is kind of how I did the original one. I want to keep in line, in the spirit of that one and the tools I had at the time. So that's what I'm going with. And also, as I said before, it helps actually glue the LEDs in. So I'm going to let these dry. And then after that comes the worst part of this project, which is the soldering. Now, these LEDs, there are 20 of them, have to all be soldered together in one big long line. And there are 3 wires. There's a power, there's a ground, there's a data. And they have to be chained all the way along. And so what I have to do is I'm going to have to cut 60 wires, because there's 3 times 20, to exact lengths to fit on the back of the board here between the various different pieces, and then individually solder each of those wires onto the right pads on each LED. Obviously there is tape here now to hold it on. I'll peel the tape off once the glue is set, and then I'll solder them on. So that is what lies ahead for me. I'm going to show you a few bits and pieces of it here and there, but you trust me, you do not want to see the full thing. So I'm going to get soldering. At the end of that solder wire, I'm also going to leave 3 cables dangling so I can put a connector on like this. And yeah, so I'm going to get to that, and then we'll come back when that is all done in probably, for me, a few hours. So that took quite a while, but at the end of it, I finally have my lovely, fully soldered together set of LEDs. Now there's 20 soldering points in here. It is a very difficult process. As you can see, it's not the best wiring and soldering job in the world by any means, but it does the job. And I've checked all the connectivity and made sure they all have power and light up and everything. So that's done, and basically, like, now in terms of the hardware, the build is complete. As you can see, I have attached the controller here onto the board, just taped on, but I'll get a better attachment in a second. And that's hooked up to the LEDs. And so the remaining job would be to write the software for this. But in this case, of course, I had a previous map, and so this actually still has that software on it from last time. I just put this in a box when I tore the old one up. And so if I plug this in now, as you will see, I can actually have all the LEDs light up in the sort of the default configuration. There is a test pattern that lights up with all the colors it uses when it starts up. And so the remaining job really is to take the existing software, modify the list of airports so it looks up to the right airports. Obviously the old one has, I think, 22 Bay Area airports programmed into it. Got to change that to 20. Got to put the different airport codes in. They are written on the back of this in order, so I can at least just do that pretty quick. So I'll show you some of how that looks and how the sort of online IDE looks and that kind of stuff. Upload it to here, and then the project will be done. So let's cut back over to the computer. All right, so let's look at the software here. Now, this is on the online Particle IDE. Now, the nice thing about the Particle IDE is not only is it online and it takes away a lot of the hassle of having to do things like downloading libraries and things, it also flashes online. This flash button in the top left corner here will over the air talk to my device, which has a base firmware, which Particle will control, and then upload this new code so it runs next time it reboots. What that means is you kind of have this Arduino-like environment here, and as you see, we're pulling in Arduino libraries from Adafruit, from the NeoPixel library, but you can still work with it kind of as Arduino and then flash it and not have to go and find the device and then drag it over to where you are, plug it in and update it that way, which is especially useful if you've got one of their LTE or wireless devices that is like in a sealed container and you can't easily plug it in to do an update. But let's look at this briefly. We have a few color definitions up here, the various colors of different weather conditions. We have a big list of airports. This is where I'm going to go and add all the airports I need to in a second. And then in standard Arduino fashion, we have a setup function, we have a loop function. So in setup, we just basically hook up some of the pins to make sure we can actually talk on them. And when we send a subscription up to Particle that says, hey, whenever I get a meta response event, I want you to call the handle weather function in my code. As you'll see in a second, this is kind of part of the Particle method of doing things, which is rather than having all the networking run on device, all of it runs in the cloud, and then the device just merely sends and receives events with text in them, and then all the rest of the processing happens on the server side. And so this says, hey, hook up that response. So now any message on that meta response channel will actually just call the handle weather device that's further down in the file. We then run through a test phase of making sure all the colors look good, and then go into the main loop function down here. Now, the main loop function merely sort of just sits there and loops forever. That's how Arduino loop functions work. In this case, if it is close enough, or rather far enough from the last update, which I think is set to every half an hour here, but don't quote me on that. You'll seen it earlier in the video, I'm sure. It then says, okay, like we need to update the different airports. And so first of all, it sends a simple started airport update message. This has no function. It's just for my own personal debugging use. It's nice to see like, oh, like it's actually doing it now, because there was a while developing this where it wasn't updating on time. I'd got the timing code wrong. So it's nice to have the ability to just publish things, and you'll see them in the Particle console. I'll show you that in a bit. So you can see what's going on with the device. So once you've done that, it goes through that entire list of airports up at the top. And then just for each airport, it pulls it and runs fetch weather. And if you look, all fetch weather does down here is it simply sends a message on the get meta channel up to the server. Now, it doesn't actually do any of the API responses and requests here. Instead, that's all configured in the Particle Cloud integration we'll look at in a second. What that integration does is it goes and talks to an API, and it comes back with a short string saying what the condition is. And that comes back on that meta response channel, which, as we saw, is hooked up to this handle weather function. So when a message comes back, it has the ICAO sort of airport code, and it has the condition string all jammed together. This merely takes that payload, separates it out, tries to basically match where that airport is in the airport list, so it knows what number LED to send it to, works out the color based on the condition, and then just sets that particular pixel by number to that color. And that's kind of all there is on the device side. It's one of the reasons I like the way Particle stuff works is that it essentially just goes. A lot of the annoying networking stuff I've done before myself with SSL and everything is handled for you. So let's jump over to the console and I'll show you the other side of this and how it looks on that side. So here's the console, and you can see, in fact, there is a log here of all the different operations that have already gone on with this device. Now, obviously the device's firmware is still in the San Francisco Bay Area version, so you can see that it booted up, it started the airport update right here, and then it immediately started querying every single airport in order up to the server. And of course, in response, the server is going to work that what it is, and it's going to send the response down. So we go look at integrations, and here we can see that there are various webhooks. Get meta is the one that we are looking at in particular. And what this does is tied into when the endpoint is called, it calls a URL on which you can pull in values from that event and put them in the URL. And then it takes the response, and then you can pull JSON out of the response into your response templates. As you see here, like the server can take the JSON that's returned from that API, it pulls out the station and flight rules keys, and then just pops them into the response as a single string. That means I don't need to do any JSON decoding on my device. It's great. And that's kind of all there is to it on this side. So, you know, it's a very simplistic use of the Particle world, and you could definitely do this in pure Arduino if you wanted to. But this is one of the cases where I like having a little extra of that sort of server-side stuff doing it for you, because it just makes a lot of the SSL negotiation and on-device code a lot easier, and having that built-in flash over the air, super handy. So I'm going to go back to my IDE, I'm going to add in all the airports, and I'm going to make sure it can pull the data for all the airports in the Colorado area. And then hopefully it'll look good and I can show you a final working example. All right, so that's all done. I've put the list of airports into the firmware, I flashed it. I then had to go and update the integration to make fix the URL because it's been a little bit since I last used it and it's changed where it is and needs authentication now, but that's not too bad. I'll make sure to link the repository with that code you saw and also some basic setup instructions for Particles Lane if you want to use their stuff below the video. But as a result, I now have a working weather map. As you can see, a good number of the airports are pulling in data. It is an almost disappointingly nice evening here in Colorado, as you can see, green across the board. But I look forward to the next thunderstorm that rolls in, which is presumably any day now, turning all of these purple and red as they go across. So that's kind of the main build. I'm going to go and put a little bit of mounting equipment on this. I'm going to pop a piece of balsa wood just on the top and bottom and just hang it on some nails for now and do that. That's my standard cheap way of hanging stuff that has depth off the wall. Bit of wood on some nails, it will hang there, it's perfectly fine. Also going to attach the board there a bit more strongly than just tape because as one would expect, it's already coming off. But yeah, that's what it takes to build a live weather map of airports near you. If you are in the very small group of people that would find this useful, now you know how to, and if you have all the equipment lying around. But it's a fun use, and it's one of those fun things where the ability to chain RGB pixels like this, the NeoPixels, is super useful. Like if I was to wire this using 20 individual RGB pixels, like I would need a common ground for all of them, but then 3 separate data lines for every single one of the LEDs. The red, green, and blue. That's how it works. There are chips that do this, but like the back of that board would be even messier than it is now if I had to do it individually. So addressable pixels for the win. They're fantastic. You can do all sorts of stuff with them, all sorts of maps, like anything you can imagine you want like state-of-the-art LEDs in. This is a good kind of pattern to do it. So that's the project for now. Thanks for watching. I hope you learned something. And until next time, I'll see you around.